problem we have the absolute value symbol. And I'm going to go up here in the upper right-hand corner and just give you a reminder on what that means. When you take the absolute value of a number, it basically just takes its negative away. So if it's not negative, it doesn't do anything. Take the absolute value of 7, it's 7. Take the absolute value of 0, it's 0. But if you take the absolute value of a negative number, it turns positive. All right? It's basically a symbol that tells you how big a number is without worrying about the sign. All right? So the absolute value of negative 6 would be 6. The absolute value of negative 2.5 would be positive 2.5. So like if you owed $6 to someone, the absolute value is just telling you how big your debt is. It doesn't care that it's negative. It's just how much is it? How big is that number? So that's what it does. All right? So it's this magical tool that turns numbers positive. So we're going to go from top to bottom. Let's just go right down the line, and we're going to take the absolute value of your input and then subtract 4. So it doesn't mean that your overall answer must be positive. It just means that whatever's in this symbol here, that's going to turn positive. And you can subtract 4 from it. So we are going to get a negative answer here, because when I take the absolute value of negative 2, I get positive 2. But I still need to subtract 4. And 2 minus 4 is negative 2. So when your input is negative 2, your output is negative 2 in this problem. I'm just going to start writing the next one. If you're getting caught up, go ahead and finish writing that top line. Now we're going to put negative 1 in, and then take away 4. So this function, this machine, takes your input, and it says, okay, input, I'm going to turn you positive if you were negative. So negative 1, the absolute value of it is positive 1. Then you need to do 1 minus 4. 1 minus 4 is negative 3. All right? 1 minus 4 is negative 3. So when negative 1 is your input, negative 3 is your output. Time to put in 0, and then take away 4. Then you're going to put in positive 1, and take away 4. And then you're going to put in 2, and take away 4. Now there's less action going on here, because when you do the absolute value of 0, it really doesn't do anything. It just keeps it 0. Absolute value of 1 is 1. The absolute value of 2 is 2. So here we go. We need 0 minus 4. That's negative 4. So when I put 0 in, I get negative 4 as my output. Now we're going to get 1 minus 4. Hey, look, it showed up again. 1 minus 4, 1 minus 4. We got negative 3. We're going to get negative 3 again. So this is another one of those problems with symmetry, because we're getting twin points. Negative 3 was our answer. Negative 3 is our answer again. Negative 2 was our answer. I bet negative 2 is our answer again. And it is, because 2 minus 4 is negative 2. All right, so let's go ahead and plot these points. Point number 1, left 2, down 2, put a dot. Point number 2, Left 1, down 3. Put your dot. Point number 3. 0, comma, -4. Just go straight down 4. This point is going to be right 1, down 3. There's that symmetry right there. See how these are like twins? They're on the same level. They're both 3 blocks underground. And then this one is right 2, down 2. All right, let's trace it. When we had x squared, the graph looked like a U. When you have the absolute value, the graph looks like a V. So x squared looked like that. X cubed looked like this. Absolute value looks like a V. Those are the different shapes that you're going to see. And we'll see one more tomorrow for what the square root function looks like. See what that looks like for next time.